Well, welcome everyone. Thank you for joining this webinar. My name is Jeremy Turpin. I'm the Chief Scientist and co-founder at Allspace, and Jasso has given me the honor of chairing this panel session. Thank you for joining us today for this topic of building the intelligent ground segment towards reducing cost and complexity with RF over IP. This is the latest installment in the Jasso webinar series that is brought to you in partnership with Proactive PR International and Nova Space, bringing a lot of valuable expertise in working with industry leaders and promoting high-quality content. Today's event is sponsored by Filtronic, who we have Ashley joining us as a panel member, so thank you. Filtronic is developing advanced RF and microwave solutions that enable high-performance satellite communications, ground infrastructure, and next-generation space connectivity applications. So I'd like to introduce our panelists today, starting with Ashley Dove, Senior Advisor from Filtronic. We have Jorg Rostro, VP Technology and Business Development at Work Microwave. We have Guy Wilkinson, Business and Technical Advisor, SSC Space. We have Javier Trujillo, Senior Manager of Digital Ground Development at SES. So to get started with the topic at hand, I have a lot of interest in the digital infrastructure for satellite, although my company and my direct interest is more on the user terminal side rather than the ground systems. There are a lot of commonalities and a lot of similarities. In addition to supporting Jasso as a co-chair of the technology working group, I also am supporting the DIFI consortium as a chair of the electronically steered antenna working group, looking at special considerations needed for the antenna, flat panel antenna market. To start the conversation, I first would like to invite each of the four panelists to give themselves a brief introduction, and then we'll move on to the questions. Starting with Guy.
Yes, hi. My name's Guy Wilkinson. I've been working at SSC Space now for 7 years, based in Stockholm for a large part of that. And I was responsible there for all of the ground infrastructure across the globe from all of our remote sites and receiving information and Earth observation data, as well as supporting navigation and TT&C for many, many missions. Previously to that, I've 25 years in geostationary satellites with Avanti and Eutelsat, and some years before that. So in total, maybe 40 years in the space industry in total.
Thank you. Jorg?
So I'm Jorg Rostro. I'm for almost 20 years now with Work Microwave. So my background is I'm a comms engineer, and I have developed satellite modems in the past, and over that, as things progressed, went on into like larger ground systems and the digitization of them. And also in the long term, I worked a lot in standardization, in DVB, CCSDS, and as of late, also in the DIFI consortium, where I'm also a member of the board of directors.
Thank you, Jorg. Ashley?
Hi, everyone. My name's Ashley Dove. My current role is working as advisor to Filtronic. So for the last year or two, I've been engaged in advising Filtronic on how they can use their technology that's been developed over the last few years, mainly around their own MIMIC development to 100 gigahertz plus, how this can be used in the SATCOM space sector. So developing the correct products and enable them to enter the market. In parallel with this, looking at the same market sector, Filtronic also has a high-speed digital design team, so developing an RF over IP solution to sort of complement this was a sort of natural next step. Prior to that, I was, for 10 years or so, I was region head for Europe, Middle East and Africa for communications and power industry, or CPI, having the same role with GD Satcom before that was absorbed into CPI. So this was looking after the business of GD and then CPI in the region. Before that, I had a long career with Vislink and the previous incarnation, starting off as a microwave engineer, moving through system engineering to solutions finishing up as VP Solutions for Vislink until the sort of mid-2010s.
Thank you very much. Last but not least, Javier.
Yeah, thank you, Jeremy. So I'm Javier Trujillo. I'm the senior manager of the digital ground development team at SES, where we are taking care of SES strategy towards digital architectures for both user terminals and ground infrastructure. And I joined SES around 11 years ago after finalizing a PhD on flat panel antennas, and I was working for 6 years as a systems engineer, sizing the payloads of the satellites and also looking into the sizing of the user terminals and the gateways. Further to that, I spent 2 years as a technical program manager for the empowered ground infrastructure. And then after that, then I'm on this current position where on top of that, we are also looking into how we can integrate the 5G ecosystem into the NTN solutions. And I am the user segment technical lead for the Iris Square constellation in the Space Rise consortium. So nice to meet you.
Well, thank you, gentlemen, on behalf of JSOA and of our audience for joining us for this panel, and I look forward to this conversation. So as the first topic, as technologists and as engineers, what we all love most is to define our terms. And one of those terms that we're going to be mentioning a lot during this conversation is Diffie. Now, Diffie is not in and of itself equivalent to digital ground, but I would like to ask Jörg if he can please introduce the concept of Diffie, where it fits, etc.
Yes. Good thing is to make it as clear as possible, it's Diffie because it stands for like digital intermediate frequency interoperability. So it's not Di-Fi or anything like that. It's Diffie. That question occasionally comes. It's sometimes, as we are part of that ecosystem, it feels very natural, but of course it's new to some that transition into it from an application perspective. And the consortium set out to solve the transport problem essentially. So when you look into a digital system, other than L-band or L-band cables or waveguides or anything, you still have to transport your digital representation of the spectrum. And there are some SATCOM-specific needs to build systems in which this transport is going to happen over a network naturally in the digital domain. And the Diffie consortium set out to form a standard in the industry, as they usually work. So all the players and even competitors come together to find a consensus on a standard that solves all these problems and continuously gets or evolves to cover all the applications and all the requirements we see from SATCOM operations for this kind of transporting spectrum in the digital domain. So it's not nothing beyond that. So it's not solving a lot of system things. They still exist, but it is a transport solution for digital representation of spectrum.
Thank you, Jörg. And so extending on that, when we say Diffie is not digital ground, Diffie is a transport mechanism for it. So that means the digital ground is greater than that. So what else is in that? If I could ask Guy, what else contributes in? We have transport. What else is needed in to consider digital ground?
Yes, in the other side of that is obviously on the signal processing, which in the past has been through modems, which have been appliances in sort of broadband systems with gateways and hubs. They've been quite large, complex combinations of modems and data processing at the back end. And now that's all moving into a generalized compute environment with software-defined radios, and it's a move that SSC Space has entered into with the Go network and making use of Kratos's open space solution and digitizers. But that's all stays within the, if you want, within the server room. We're not yet extending it out using Diffie to the antennas, and that is very much probably a near-term step for the company to evaluate, and we'll come into some of the topics that will drive that faster or slower.
So we've addressed a couple of terms. I think there's a few others, including Wave and Vita49. Javier, you might have a few comments on those?
Yes, related to that, I think what is really important into this digital ground infrastructure is all the standards that they need to be in place so that you make sure that all different components that you will be using to compound this architecture, then they are in place. So for that, as you mentioned, we have Diffie, that it is what it is standardizing the way that we sample the RF signal and we packetize it into IP packages. So then we can have a network between the digitizer and then the software-defined radios that Guy mentioned. And then on top of that, we have the wave the wave standard that it is working to standardize the way you actually implement your radio, your software radio. So you would be able to reuse the same architecture independently of the vendor that is implementing the solution that would help you to get this software-defined radio.
So a question to all of you, and speak up as you see. What has been the impact of digital ground technologies on your respective businesses?
I might take that first, I would say, because as an equipment provider, it changes essentially everything we provided so far into a new domain. And what we see at the moment is still a one-on-one replacement. So instead of an analog interface, it's just the same thing, just it uses a digital interface. So we still go to L-band and then we digitize, and then we might have a network interface and a modem instead of like an L-band interface. But when we look further, we actually expect much more that the whole system infrastructure is changing. So this just started, and in many ways, Guy might comment on this, because like usually the downlink of space data is sort of the simplest case I know, because it's usually not so much related to latency. But on the other hand, we still look forward to issues that more satellite communication, like Javier might be using it for networks and that is latency prone, might be able to solve. So it changes the whole thing, how we look at these systems, how we design these systems, and eventually what solutions are going to be needed. It's not just a one-on-one change from a kind of analog to digital. It really resets the whole thing, how we look at what our customers do and what they need as a complete solution, how they distribute their signals, where the processing takes place, and what their requirements are in particular. And with the board we have like right here, there is the range of this present, and it is very interesting to see how they differently adapt to these things.
Yes, I think from an operator's point of view, we're a ground segment as a service provider, so we support many missions. We aren't the system designer, so we don't control the complete end-to-end system. So we're providing the ground link for the different types of missions, which can be quite varying. But I think one thing that maybe just coming back to a little bit of sort of the evolution of the transport technologies. In the old days, we put everything as close to the antenna as possible because there's coax cables. Last 20 odd years, we've been using what we would call RF radio frequencies over fiber, but that requires a dark fiber. It works well on site for interfacility links across large sites, and allows a lot more flexibility in the deployment of your infrastructure. But using it across a WAN network, it was always a challenge. I have some experience of doing that with K-band gateways, where we wanted to have diversity for the weather, and we didn't want to duplicate all the equipment in two sites which were nearby but separated. But getting WAN links, dark fiber, because RF over fiber is analog. It's not an IP transport system. So I think that's where the Diffie will open up so much more flexibility in the way in which you design. But I have to caveat that, because also there's the bandwidth issues associated. I mean, I think it's important we understand that when we digitize the spectrum, we increase the RF bandwidth, which maybe 100, let's say it's 100 megahertz on the spacecraft down to the ground. It would be a factor at least 5, maybe even up to 10, depending on the fidelity of the signal that you need to reproduce. So that means that you suddenly move, even a narrow band signal can become wider band, and then depending on your topography of your sites and so on, it means that you have to be very conscious of the bandwidth requirements and obviously the performance of the WAN in terms of packet loss and jitter and latency and so on. So the advantage will be huge as and when we can solve some of these underlying issues. Bandwidth prices for WAN networks is steadily decreasing. That will help. But I see the market for us is firstly on the sites, improving the infrastructure there, because across site we are in control of that network infrastructure, and then probably in our more narrowband services initially, which may allow us to centralize some of our processing, which again would bring huge benefits and flexibility. So there's probably quite a lot in that to unpack.
Yeah, I mean, the pick one thing up, in particular the bandwidth, this is definitely going into the system design, saying you have to judge that which part of the spectrum you really want to transport for, and you can use channelization to dissect basically assembled spectrum into smaller parts if in the digital domain. And it's a crucial part of the system design to actually figure it out, which parts do you want to transport on the expense of the bandwidth you need for it. And so there's no clear line. It's a range between the distances, your network capabilities, and the effort you want to put into it, how far you want to transport that, and how safe you want to be with it. That's a real important system design question.
Yeah, I agree. I mean, from the Filtronic viewpoint, Filtronic's a manufacturer, and designer of solutions and specializing really in the high bandwidth gateway requirements. And it's, as I said in the introduction, we're looking at the different aspects of that. And the way the market seems to be going is that you have to provide a complete solution on a remote site to do that. So an antenna is a complete integrated product rather than an integration. But you're absolutely right that this relies on the quality of service of the connection to this site. Channelization is key there. So, I mean, to my mind, it's one of those things as you decide on the channelization at the terminal to effectively where the signal's going to go. Is it done downstream in the software in the software domain where you get other latency issues? So it's thinking through all these things as to how we have to incorporate these aspects into the evolving products. And it's going to be it's not just going to be a big effect on the business, it's going to be a big effect on the whole market of this application.
So, Javier, did you have something?
No. I mean, I was just only going maybe just to add a bit that just in the end, the infrastructure that we have hosted on our gateway sites will change compared to what we have nowadays. Nowadays, we have a hardware that it is dedicated for each of the specific vendors, and then in this case, we will move into an infrastructure that will be common and share between all of these vendors. And on top of that, we will have two flavors, let's say. So we can have one in which we have all the hardware deployed on our gateway site, or we could also select to just move directly into the cloud. So we don't have to do a big investment on the CapEx side of the gateway. and just moving all of those expenses into the OpEx and linking those expenses to actual active services that we have at that moment to provide some services, right? So that I would say that is an advantage of this type of architectures.
So I'd like to invite the audience in particular. We will be accepting and reviewing any questions that you might ask through the interface. So please do submit any questions that you might be interested in having us address. To the panel, I believe Jorg, you mentioned that in one sense, yes, the digital architecture, you're just replacing cables, but it's a lot more than that, of course, as you called out. But what are those other capabilities that digital technologies bring? What are those additional considerations or benefits of moving to a digital ground technology, other than those that have already been called out? Well, sure, we can separate hardware from the antenna, perhaps. We can centralize. It may give some better scalability. What else is there? Start with Jorg and go through the.
Yeah, I mean, considering the higher frequency bands, for example, so when you look at Ka band or even QRV band, you have much larger spectrum available in the RF domain than you have actually in L band, which is currently, let's say, the analog way of distributing signals locally. So the L band is about 1.2 gigahertz wide, while you have like 4, even 5 gigahertz in the RF. So when you go into the digital domain, you basically don't have to put that down in various L bands in order to get like the whole coverage of the spectrum. You digitize either directly or in practical terms, you can maybe at the time digitize X band directly, but for Ka band, you would want to use probably one conversion stage. But you don't have to go to something like L band, which is very inconvenient from where it is in the spectral range to convert to and to digitize. You can put it in either, for example, 0 to 3 or 0 to 5 gigahertz, or maybe the second Nyquist zone, and then sample directly the whole band in one step, which is a huge data rate. So it's even, consider something like the factor 12 or 16, depending on the bit depth, rather like Guy's conservative approach on it. But then, as I said, you use a channelization locally and then arbitrarily distribute your streams either on site or further, depending on your application, not depending on the limit of the distribution band you have. So that opens up a whole lot of thought on how these systems look like. So you would have basically an integrated antenna with a network connector. That's the thing you should imagine, and then it's much easier to deploy that and to put it somewhere. So this whole thought of how to deal with the spectrum then slowly will change what you actually do with it, and it opens up new ways of, for example, site diversity in terms of when you have the spacecraft case where you need coverage around the Earth, or when you have multi-communication case where you rather have kind of a service level where you need redundancy. So you use a network redundancy, you stream to different positions, you just switch it over. You don't need like an operational RF redundancy with like a almost physical switch. So this kind of service level is an aspect that that comes into play as well.
Yeah, maybe I can complement what you just mentioned, but what I see the main advantages is maybe the first point is that we are removing the vendor lock for the hardware that we have deployed on the gateway side, so we can reuse. If we don't have that specific service, we can reuse the hardware that was used to deploy a specific vendor with another one. We by focusing on making sure that we make good use of the existing standards, as we mentioned, Diffie and Wave, or even some commercial products that they are already available, that, like for example, Open Space. So we can consolidate the infrastructure that we have to deploy on the gateway. And we are also removing the lead time for the hardware. Sometimes we just get a customer that wants the connectivity now, and unfortunately the gateway that we have there is not sized properly for that specific platform. So we could avoid this by just making use of that hardware that was already deployed on the gateway side, or using a cloud deployment if that is needed. And I think also something interesting that can be done is that we can better protect our know-how with the waveforms, for example. So in some critical deployments where we do not want to expose that specific hardware, we can keep it in country and get the antenna, for example, deploys on specific areas and then reach out home for that key knowledge that we have there on the waveform, let's say, so we can protect it that way. So those are some of the advantages that I think they are relevant to highlight for digital platforms.
I can follow on from what Javier just said about that aspect, rather than just for sovereignty or territorial issues. I mean, we actually have a customer that's using a digital link because they're using one of our sites as TT&C backup. It's S-band, so it's narrowband. And they obviously want the diversity of sites. It's a very secure system. So in the past, they would have to have had crypto keys and all the security issues placed at our site for what if nothing ever happens, would only be for tests and rehearsals. So by digitizing the spectrum and taking that back to their mission control center, they don't have to process any telemetry on our site. They don't have to have any security risks. They're just transporting over the WAN link, the pure spectrum of the coming from the control links for telecommand and telemetry. And that, so I think that's probably our first actual commercial operational use case that we've already seen deployed.
Yeah, from my point of view, I mean the two most common conversations I have with people who are looking to go down the sort of digitization route is one is security, just as Guy mentioned there, and when you explain about you're digitizing the RF, the security therefore is much enhanced. The encryption is not required, all this type of thing. That a lot of people in that type of sector latch onto that straight away as this is a very good thing. The second most common one is you mentioned there about moving up Ka, QV, and E-band, which is sort of electronics sort of core area. There's a lot of bandwidth available, and people can say, oh, we can have 2.5 gigahertz wide carriers, etc. But then they're stuck on this L-band concept of multiple IFs and how is that done? And again, when you then describe that you consider the RF over IP as just the modulation, whatever bandwidth it is, it arrives at a site. You then go into digitizer. You can put that onto effectively any IF you want within the limits of the design, maybe up to sort of 7 gigahertz or so. And in the system, that is then a simple single up conversion to the wider bandwidth. And people are saying, well, why is there no standard for these 3 gigahertz, 4 gigahertz, 6 gigahertz IFs? And then my answer then is, well, there doesn't really need to be, because it can be really whatever you want in this type of scenario. So it's those type of conversations that I have with customers, mainly on the overall digital ground side. But of course, my conversations are really around the outlying terminals rather than the overall system.
So looking at the traditional SATCOM and broadcast industries, there's been a lot of disruption of late, which we're all familiar with, a lot of which is driven by very strong vertical integration, whereas for many years, the traditional SATCOM has been driven by a robust ecosystem of companies providing different services to and among each other, of which we have a real cross-section on this call today between operators and subsystem providers and service providers for satellite connectivity as a service. How do each of you see a change to a digital ground impacting or not impacting the greater ecosystem of how does traditional SATCOM need to work? Just changing to Diffie, is that a change to that or no? Or digital ground in general, not limited to merely Diffie?
Yeah.
Sorry.
Go ahead, please, Guy. Go ahead.
Okay.
So,
I was.
Let's start with
Okay.
Guy. Let's start with Guy.
Then let's start with Guy. Yeah.
Okay, thank you. I was just thinking back to the days of the transition from analog to digital TV, because I'm old enough to remember it. What created the success, and DVB waveforms are still probably almost close to state of art as they've ever been. So they're pretty much at the theoretical limit. So I mean, where was the success? And that was clearly the standardization process, and the market volume. So, as you rightly point out, in a ecosystem where if you're not vertically integrated and you don't have a huge market to benefit the volumes and the investment in amortization, standardization becomes absolutely critical, because it means that you have many smaller players can risk investment in their part of it because they know they can compete on a reasonably equal footing, at least for making things work together. Of course, there'll be performance differences, feature enhancements, all the usual things, but without that standardization, it won't. It certainly, from our point of view, would be very difficult, because, and I think already Javier's mentioned about vendor lock-in. We run a very heterogeneous network. We have antennas, some of which are 40 years old. We have a lot of new ones, but it's the advantage of the analog world is it's hundreds of years old. So you have a very simple, some respects, standard. It's sometimes difficult to implement because you have to understand it, and it's a technology which is in some respects less and less supported, but has a long history and a long proven track record. So I think the standardization process of Diffie is absolutely key to this. And it's great that we can see now moving from the plug fests and into the sort of certification groups and the fact that we have test and measurement people on board, because I think that's really going to drive the confidence that you can deploy this and know that it's going to work, and not spend all your time debugging between different equipment manufacturers' interfaces. It's got to be like an Ethernet, connect it up, and as long as you remember to take off auto negotiate so that you fix your bandwidth, then it's fine. But you need something which is absolutely plug and play to make to get all the benefits that will come downstream.
Yeah.
Ashley, I believe you had a comment.
Yeah, I think interoperability is key. It's the manufacturers are involved through the Diffie consortium, in interoperability testing, and we all need to know what to design to, and users like Guy and Javier need to know that the equipment that they're getting is interoperable. I would go so far as to say we need some kind of standard that the equipment is tested to, that it meets, but I don't think we're quite there yet. I mean, I can't really comment on that apart from knowing we're not there yet. I think it's a seismic shift in the ground segment implementation, everything being focused really just on the outline terminals, just around the antenna terminal as a product, and then you need the very high quality of service interconnect if you're using terrestrial, and the systems in the hubs, data centers, the software modems they're providing the information for transmission. Everything needs to be interoperable, otherwise this thing's going to fail. Yeah, people are going to stay with what they've got rather than change usual scenarios or spend many man years debugging the implementations.
Jörg?
Yeah, I mean, plus one to that. It's exactly the standard creates ecosystems, and that has quite already come a long way for the space communications or the Earth observation downlinks and what SSC, for example, is running, and also the TV distribution. But if you look at research systems today, they are still operating at the equivalent if T-Mobile would only give out their own handsets and there would be no iPhone and no whatsoever. So this is something that struck me as odd since I work in the satellite industry. And maybe with the digitization of the ground segment in general, with the direct-to-device operation being around the corner, our industry changes in mindset and enables this kind of ecosystem, which would be much more prolific and open to the general operation and enable much more people to actually use satellite communication. So this is the step I hope we take as an industry. This doesn't mean necessarily that like all communication will be direct to device. There are still a lot of different, much more wideband satellite communication, but it will become part of a more open infrastructure, which has a much lower entry hurdle for anyone who wants to join in whatever capacity. So that is what I hope as an industry we achieve. And as Work Microwave, we believe in standards and that kind of ecosystem, which is why we also engage in, I mean, it's a cost. So when you write a standard, you have to send people there and experts and contribute to it. But I only can, put out a message that invites people to do that because it's a lot of benefit that gets back to you. You become part of the ecosystem and the actual ecosystem. So the pie gets bigger. It's not that you want a bigger share of the pie. It's like you get automatically a bigger share because the pie gets much bigger.
All right. There are a couple of questions on the chat. So one of them is around the Diffie compliance, and this one I'm going to send to you, Jörg, for obvious reasons. But is Diffie compliance in an RFP or in a specification or the requirements for a network or for a from an operator, is Diffie compliance verifiable today, or is it still only self-attestation?
So it's at the verge, I would say. So we recognize that. So for once, there might be different applications. So there's not a hard line between like only compliant or not compliant. We have to be a bit specific about what exactly you want to do. And there is a specific working group covering that, which will enable a certification that is like a third-party certification according to certain or a set of parameters. So you can be certified, or the products can be certified so that as when you RFP, you have like easy access to like a third-party proof that the products that have been or claim having certain functionality actually really have that. That's currently really in the making since we just finished. So we just finished the standard 1.3, which covers a lot of like link establishment that is necessary for satellite communication to actually create the system. And the certification naturally is a bit behind. And we expect this next year to be really in place and be in a shape that it can be directly put into RFP from an outside perspective.
Thank you, Jörg. Looking at Javier, as the operator on the panel, can you share with us some of the plans that your company's making for moving to digital ground in one area or another of your operations? Are these, what sort of benefits is SES looking to get from from Digital Ground? And is this something that's going to be customer facing or giving you enhanced operational efficiencies, or what?
Yeah, so on our side, on SES, we are clearly looking into digital architectures for both the gateway side as well as the user terminal side. As we see, yeah, clear benefits. I think some of them I already mentioned before, like for example, reducing the footprint of the gateway side, so we can have this common hardware. By having the same common hardware, then we can reduce the complexity of our operations. So we are expecting to ease the operations of the gateways. Another point that we see, for example, is that we can disaggregate the software features upgrades from the hardware. Since now the hardware is common and it's the same, we are expecting to get faster updates of these of the features that we can enjoy on the platforms. And maybe I would reiterate again on the TCO and the advantage of being able to move in more towards an OpEx-based solution that we can actually link all of our expenses to active services and reducing as much as we can the initial CapEx expenses that we need to do in our gateways, I would say. Well, and I think I mentioned a few more before, but just so that avoiding trying not to repeat what I said before, I think that's what I would highlight.
No, thank you, Javier. There's a couple of questions on the chat around the bandwidth. So we've already emphasized that one of the biggest challenges with Digital Ground, or concerns, or points of confusion, all of which I think are accurate, is you need a lot more data. We threw out, well, you need 5 or 10 times as much baseband if you're thinking the actual signal rates on the fiber in order to carry a given spectrum of a digitized spectrum. So I think it's right to say that is one of the bigger challenges, but at the same time, it's not necessarily a reason for concern. One or multiple of you like to give some indications and put some real numbers on what sort of capacities and data rates are being driven and why this either is or is not workable with today, and where the limitations are?
I can.
Yeah, Ashley?
Oh, Ashley, yeah.
Yeah. Okay. I mean, without going into specifics of particular signals in particular bandwidths, and having to work that out, I think a good rule of thumb I've been sort of using based on what's come out of the kind of Filtronic design is, if you're talking, for example, of 1 gigahertz wide IFs at the moment that are digitized at depending on the sampling rate, sort of 10, 12 or 14 bit. If you've got 6 signals that occupy that type of bandwidth, you would just about, if you're lucky, be able to get them down a reliable 100 gigabit link. Now, when you're talking wider bandwidth signals, obviously they wouldn't do that. And this particular unit has the capability of 6 transmit receive IF interfaces, each out to 2.5 gigahertz bandwidth. So there is no way you would get that down a 100 gigabit pipe. So the simple solution to that was enable a second 100 gigabit connector, but of course then you've got to have 200 gigabit pipes. So I tend to work on that kind of basis, that if you've got 2 or 3, 4 IFs of up to a gigahertz wide, they should reliably go down a 100 gigabit pipe, depending on the quality of service, of course.
Yeah, on my side, what I would say, I think it is much more of a concern when you are looking into deployments that they are involving the cloud, because in that case, you need a very high speed connection to that. So maybe the cloud provider should be looking into packages that they would need to include the transport of the signal from site to their cloud site in that case. But if you have an on-site deployment, of course, it is something you need to pay attention, make sure that you have a good connection from these digitizers into the channelizers and this IP network that we were mentioning we would need in between. But I think it is workable.
Yeah, to give some numbers again, you would probably want to look into, for once, the sampling depth you actually have. So if you have multiple signals combined, you need, I would say, at least 10 bit, because otherwise you already get issues with the signal processing and the modulations. And then you have at least 1.25 the factor of your actual bandwidth. So that makes it a factor of 10 minimum. So for a gigahertz, you have at least 10 gigabit, but it's like the lower end, definitely. With higher sampling rate, you exceed that much more. So I absolutely agree with Ashley. If you have a 4 gigahertz bandwidth, then your 100 gigabit network already becomes crowded. And yeah, that's something really to consider. And this is actually, we mentioned the channelization earlier, and I want to highlight that again, because this is a stage between the digitization and the actual signal processing in software modems or whatever, where you distribute, you dissect, or on the transmit side, you combine your signal as well. So this is the part that manages the distribution of the signal and solves that problem in your system design. And imagine that as purely digital processing, but is highly likely to be something that is like FPGA accelerated. So it can still run on standardized hardware, but it is accelerated, and it's a crucial thing in the design where to put that in order to get hold of these bandwidths. So while you might have infrastructure to distribute 100 gig without problems on a certain site, you might not be able to distribute the same thing around the world. So it's essentially how to design this kind of network distribution in order to get hold of these bandwidths.
So I think the bandwidth question that plays into which applications I think will adopt or can adopt digital infrastructure quicker than others. And as I said before, TT&C is narrowband, and that for us is definitely the first opportunity to take advantage. Then once you move up in frequencies, for Earth observation data downloads, X-band, typically 400 or 500 megahertz of available bandwidth. Some missions may use most of it, some may use less of it. So you're into the hundreds of sort of megahertz there, which is probably doable with the technology that is available today or about to become sort of available. But as soon as you get into the higher frequencies, I still see there's bandwidth challenges is quite demanding. Even for Earth observation at KA, we have 1.5 in the downlink on potentially on two poles. Now, not all missions, very few missions are using all of the bandwidth on both poles, but I know there's an ambition to do so because they want to download higher and higher resolution data, and get more down in each pass to improve the response time or the timeliness of the images. So, you know, we even in Earth observation at K-band, you're looking at 3 gigahertz potentially of spectrum, of which, yes, you can channelize, but it's going to be it could be 6 500 megabit channels. So you might be able to split them out into smaller interfaces, but ultimately you still got the data there. And then, of course, if you go to SATCOMs, and if, as in some projects, are looking at using 3.5 gigahertz on two poles, you've got 7 gigs that you need to distribute. That's still, for me, I'm looking at that, is a challenge. And then if you bring that all, if you replace your good RF matrix switch, L-band matrix switch, with a network switch with 64 or 128 ports, then if each of those is 100 gigabits, then you have a pretty big backplane. I mean, don't get me wrong, the network technology is moving very fast, and there are some very high-speed network equipment, but it's not cheap. I still think the current technology is and the standardization is going to enable the narrow to mid-band, and certainly for terminals where maybe 500 megahertz is more than enough, it could be very interesting. But I still think on the very high bandwidth side, it's a challenge to anything other than maybe a cross site at this stage. But that's my assessment so far. The things changed so fast.
They do change fast. That last question raised a lot of, I'd say, common concerns about digital ground, and I'd like to dig into that a little bit more as well. What are the hesitations that either you have had to overcome in your organization or for your problems, or that are common concerns? So we've already mentioned that bandwidths are high, and well, maybe they're not too high to be challenging. Network switches are expensive, but not prohibitive. What are the other limitations that people considering digital ground might need to maybe not be so worried about, that you've decided can be overcome, even though they sound quite risky? Ashley, perhaps to start with?
I mean, talking about challenges, if that was the emphasis of the question, I think, twisting that round a little bit, I think I've had a lot of people discussing with me about basically operational costs, which we've kind of touched on, and people saying, well, it looks very nice on a piece of paper. You can draw that you've got all this equipment on a site, and you have to rent a building. There's cross-site cables, there's L-band matrices, all these type of things. Can we just eliminate all of this? And the simple answer is yes, you can, but it's not that easy for the reasons we've done that. It seems to be that this seems to be the driver that they're wanting to find ways of doing this, because it can save, I'm told, a lot of operational expenditure in renting buildings and supporting equipment on sites and this type of thing. So the challenges from the manufacturer point of view, of designer point of view, there is how do we, if the desire is to have this, if you like, antenna terminal with just a fiber and a mains connection, everything goes there, and that's sat on a concrete plinth and everything is integrated on it. What else do we have to do to, as an RF manufacturer supplying this other equipment and then interfaces, what else do we have to include in there to make this a viable solution for the operators, for them to reduce their operational expenditure? And we've mentioned about channelization, if that is done at source, where it can maybe be done in hardware, much with less latency, or is it better relying on a high data rate connection and the channelization done downstream somewhere where there's another router or something else? So we're very much at the moment see the challenges gathering this information from the users, the marketplace, the operators, as to what else do we have to implement in a solution like this. Because if you take that one step further, the way this is going, again with the RF manufacturers head on, is that on a satellite terminal, you've got an uplink chain, you've got a downlink chain. The interface on those is going to be some kind of RF over IP to some standard, presumably Diffie, going forward. So this has to be integrated into the products, much like an Ethernet control interface is standard now. So that has to be adopted. And in the meantime, we have to have a box that would do all of this interface in the system itself. So getting, everybody has different ideas about what it needs to be incorporated at this level, but it's interesting to get the feedback from the people who talk to a while about what they think needs to be in a terminal that can just be deployed, left alone in there. So that's the biggest challenge, I think, from my point of view.
What I would just add maybe is just I think still the maturity of the standards needs to be improved. Maybe Diffie is the one that is most advanced, but there is still many things to be fully put in place. Also, vendors, well, interoperability on one side, as we said before, just making sure different Diffie suppliers are actually really properly interoperating, but just not only in Diffie, also in the other standards like in Wave and so on, making sure that they are able to use the same hardware. And then also just making sure that the current standards that we have will be compliant with the next generation platforms that we are heading towards, like for example 5G, and making sure that we'll be able to reuse exactly the same hardware to also support those other
Yeah.
coming systems.
Mhm.
It's key.
Yeah, I mean,
Yeah.
there is also the point of latency. I won't deny that. So whenever you have in the digital domain, getting something from A to B, you have a buffer at both ends, which introduces latency to the system. To some applications, that's more crucial than to others. There is, of course, ways to configure that, but also with regard to your system and its abilities, as actually who sets it up for operation has configured it wisely. Otherwise, you screwed it up through your whole chain. That's definitely a challenge still, and that might be one that not all people are aware of. I mean, some people are aware of that it exists, but not about the solution. And even the ones who are aware of the solution might not know how the constraints are in the practical world. So getting this known and together across the board, saying, hey, this exists, it can be served, but it has to be chosen wisely, is to me still one of the main aspects for a digital infrastructure.
Yeah, latency is key. That is true.
All right. We have just a couple minutes left. And so for one final run through each of the panelists, I'd like you each, I'll go through in order, but one final 30-second sign off. What is driving you most interesting, most exciting about the transition to digital ground from whatever perspective you think? I'll start with Guy.
Well, I think going forwards, it's going to be removing a lot of the RF issues, the analog RF issues, which we all live with in operations and requires quite a lot of special skills and people to be able to diagnose. So I think, if we can get a good, reliable digital signal, we know that that's probably a more stable operational environment, and will certainly in the future be better supported and easier to support. So I think that's really and then all the flexibility that will come with software-defined radios, working with digital signals, and maybe you'll say something about electronic steerable arrays in terms of getting the processing right up to the antenna and not messing around in the analog world. But yeah, so that would be where I'm hoping it all gets to.
Thank you, Guy. Ashley?
Yeah, I think again, from my point of view, it's thinking really of the sort of gateway terminals, that type of thing, and yeah, it's how do we present these such that they can work with a fiber interface, and make sure that the customer understands what is needed in terms of the sort of bandwidth of interface there. The other area is we touched on briefly, promoting the security aspects of this, that all the processing and everything else around the data is done at source, so it's just the RF that you're dealing with in the antenna system. You don't need so much encryption or anything like that, and again, making sure that the marketplace, the customers understand these issues and helping to get this across. And the key thing for me out of all of this is the standardization. Everything's got to work together, otherwise we won't get off the drawing board, as I think they used to say.
Javier?
Yes, so I think on my side, just to highlight, so I think we need to further work on the standards just to make sure that they are all completed. We need to increase the vendor pool that we have supporting those standards and implementing them. And I really like of this technology that we can link it to service, so the cost can be transitioned into more of an OpEx plan that we can justify that cost. And then we need to make sure that this technology and the standards that we are developing, they will be compatible with the upcoming technologies like the 5G, that also 5G will enable the interoperability between different operators, for example, as well. So
Thank you. York?
Famous last words. I mean, in all domains, digitization and virtualization led to a kind of a ubiquity of the service or the application. And I think the same is going to happen for SATCOM in many ways. It has its own challenges and it's quite a long process, so it will take some time, but it will make it more integrated and more available to, yeah, worldwide, to a wider user group than it has at the moment, definitely. So it will be more integrated part of comms ecosystems, and I look forward to that.
Well, thank you all very much for joining us. If I had to pick one word that summarized the most conversations, it is standards and standardization. I definitely, on behalf of the shameless plug, on behalf of the Diffie working groups, I certainly invite more people and everyone interested to join in the conversations there and join those organizations for Diffie, for Wave, and for others. This brings us to the end of today's discussion. So thank you to the audience for giving us an hour of your very valuable time. Please keep an eye on the website, on the JSOA website. I believe that the video will be made available, and some of the questions we'll see if we can answer that we weren't able to get to. The JSOA webinar series will be taking a short summer break. We look forward to welcoming you again back in September, and we're going to continue addressing some interesting topics, and we hope you'll join us again. In the meantime, see the website. There's a lot of previous webinars available. And thank you again to our panelists for giving us your time and your thoughts. I certainly enjoyed this conversation.